For the quadratic function f of x equals x squared minus 6x minus 7, we want to find the orientation, vertex, axis of symmetry, intercepts, domain and range, and also graph the parabola. And we're going to use completing the square to find the vertex. So we're going to start off by understanding what is the general form of a quadratic function. The general form is f of x equals ax squared plus bx plus c. And to determine the orientation of the parabola or quadratic function, all we need to know is the value of a. A is the coefficient on the x squared term. For our example, the coefficient of our x squared term will be a 1 since no coefficient is listed. With a being a positive value, being greater than 0, we know that this graph, the parabola, will be oriented up. We'll have a parabola that opens up that looks like this. So anytime we have the value of a being positive, the orientation will be up. Then we want to find the vertex, and we're going to find the vertex by completing the square. So we're going to start with our function f of x equals x squared minus 6x minus 7, and we're going to start by factoring out this leading coefficient from the x squared term. In this example, because we have a coefficient of 1, we don't have to do this step, but if there is a coefficient there, you want to factor it out of both the x terms. And you're going to leave that constant alone, and you're only going to group your x terms together. Then the completing the square process begins. You're going to find the magic number, and you're going to find the magic number by starting off with the coefficient of the x term, which is -6 in this example. So I'll do this on the side over here. We start with that -6, and we're going to divide it by 2 and then square it. So -6 divided by 2 is -3, and -3 squared is 9. And that's the magic number that we want to add inside the parentheses. So we're going to add a 9 inside the parentheses, and we need to balance our function by doing the opposite of what we've just done. Now we've added 9 inside the parentheses. We need to consider if there is any number in front of this parenthesis as well. So that would be a 1. 1 times 9 is 9. So to balance the equation, I have to do the opposite of that, which is to subtract 9. So since I've added 9, I need to subtract 9. So this will give me x squared minus 6x plus 9 minus 16. Now I'll be able to factor what's inside the parentheses, and it'll become a perfect square trinomial. So this will factor to become x minus 3 squared minus 16. So what we've done is we've taken our function from general form into the vertex form, and when it's in the vertex form, you can write down what the vertex is. It will be hk. So the vertex for this example is 3, -16. Now there's an alternative way to find the vertex, and that's using a vertex formula. And the vertex formula is that the x-coordinate of the vertex is -b over 2a. And for our function, a would be 1, and b would be -6, and c is -7. So -b, that's -6, over 2 times a, which is 1, would give a positive 6 in the numerator, 2 in the denominator, and that's 3. So the x-coordinate of our vertex is 3. We can find the y-coordinate, k, by substituting that value of h into our function. This would give 3 squared minus 6 times 3 minus 7, 9 minus 18 minus 7, that's negative 9 minus 7, which is negative 16. So you can see that we got the same vertex that we got using completing the square. So we found the orientation and the vertex. Now we want to find the axis of symmetry. And for a parabola, if you draw a vertical line that passes through the vertex, you get a line this line of symmetry. Around this vertical line, the parabola is symmetric on both sides. So what we need to know is the vertex in order to state what the axis of symmetry is. So the axis of symmetry will be a vertical line. The equation of vertical lines is x equals, and we'll use the x-coordinate of the vertex to state what that vertical line is. So the vertical line, x equals 3, is the axis of symmetry for this function. We also want to know the intercepts. Let's start by finding the x-intercept. So if we have the function, which is f of x equals x squared minus 6x minus 7, and we want to find the intercepts, we'll find the x-intercept by letting y equal 0. This is written in function notation, so y is f of x, and that would give the equation 0 equals x squared minus 6x minus 7. Let's try to solve this by factoring. X times x is x squared. 7 times 1 would give 7, and if I have a minus on the 7 and a plus on the 1, we've factored our quadratic function. I can set each one of these factors equal to 0 to get x equals 7 and x equals 1 for our x-intercepts. And then we want to find a y-intercept. So we start with our function f of x equals x squared minus 6x minus 7. To find a y-intercept, we'll let x equal 0. So I'm substituting a 0 into the function, which gives 0 squared minus 6 times 0 minus 7, and that is negative 7. So we have our y-intercept at negative 7. So I think we're ready to graph this function and find the domain and range. So to graph the function, I'll plot the y-intercept and not the y-intercept, the vertex, and it goes off my screen a little bit. So since that went off my screen, I got a different grid, and now I can plot that vertex at 3, negative 16. We have x-intercepts at 7, and I think I made a mistake here. This is x plus 1, so this x-intercept should be negative 1. And then we have a y-intercept at negative 7. And keeping in mind that this point here is the vertex, and the vertex will be a turning point for the function, creating a little minimum value in this case. and that gives us the graph of our parabola. And now it's also easy to see what the domain is. The domain will be all real numbers, negative infinity to infinity. And the range, you can see, will start, the range is the y values. The range will start at the vertex, which has a y coordinate of negative 16, and go to infinity. So our range is negative 16 to infinity. Finally, we want to state where this quadratic function is increasing and decreasing. So if we take a look at our picture, we're going to trace our graph going from left to right. So from left to right, you can see that this portion of the graph have y values that are decreasing, and this portion of the graph have y values that are increasing. And you can see that that dividing point is at the vertex. And we're going to use the x-coordinate of the vertex to separate these two intervals. So we have a function that is decreasing on the interval from negative infinity to 3, and increasing on the interval from 3 to infinity. Now I've written this with parentheses. There are different definitions that involve increasing and decreasing, and sometimes the definition includes the endpoint and sometimes it doesn't. So pay attention to the wording in your textbook to decide whether you want to include these endpoints or not. So you might need to have brackets so that the endpoint of that interval is included. Thank you for checking out my videos. Have a great day.